Okay, this time we have directions that say expand our exponent. So this one says that we're going to raise the 3 and the y both together to the 4th power. So that means I'm going to need to write them all out. So that means I'll have 3y, 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 and 3y, 4 times. Because everything gets raised to that 4th. Now this one is a little different. This one, the 11 does not actually have an exponent. So the 11 gets written one time. The x, on the other hand, is raised to the 3rd. So we do x 3 times. And the y is raised to the 5th, so we actually have 5 y's to raise. The point of this is that you understand not only what an exponent means, but also how they are different when parentheses are involved and when they're not. Okay, this time we're on to simplifying expressions with exponents involved. This can be kind of a tedious task sometimes, but there's some patterns that you want to look for. Like in number 19, what I want to do first is work with these regular numbers, because I can't just divide 14 and 8. The only thing I can do is reduce them. I don't want to put a decimal answer in here, so I just want to reduce this fraction. So 14 over 8 reduces to 7 over negative 4. Okay, now the other thing I'm going to do is fix these negative exponents. So this negative 5, if I want it to be positive, I have to bring it up to the top of this. So I'm actually going to make this positive 5 by doing that. And same thing for this negative 2. I'm going to bring it down to the bottom and make it positive 2 instead. And then the y terms are already positive, so I'll leave them alone. Now I can simplify this a little bit. The numbers are already done, so we can leave them alone. Now here, when we're dividing exponents with like bases, 5 minus 2 is what we're going to do, and that's x to the 3rd. Notice that when I do a subtraction, it always starts out on the top, regardless of what I get as an answer. And then here, 3 minus 5 gives us y to the negative 2. Again, I put it on the top of it initially. But because this one is negative, it has to go down to the bottom. So my real final answer to this is going to have this on the top and y squared like that on the bottom. For number 20, you have a similar kind of problem, except in this case, you actually have an exponent on the outside, so all of this stuff will be raised to that too. My tendency is to go ahead and actually square everything in here, but some people like to do it the other way around, which is to simplify all this and then square your final answer. That's okay also. So I'm actually going to go with that method because it seems to be the popular one. So let's just focus on what's happening inside the parentheses for now, and we'll keep that square for later. So if we look at this, just like the other problem, we have an x to the negative 1 on the bottom that I'm going to bring up and make a positive 1. And then there's the x to the 3rd that was already there, and the y. And on the bottom, I have that 2, and that x to the 1 is now gone up to the top, so the only thing left is the y squared. Now I need to simplify this out a little bit. This is going to be x to the 4th when I add the exponent. And for the y's, I actually have y to the 1st minus y squared. So 1 minus 2. That's y to the negative 1. And this is all over 2. We still have the square up. Okay, so we need to fix that y to the negative 1, bring it down to the bottom. So we actually have 3x to the 4th over 2y. And finally, we have to square all of that stuff, because we're done simplifying inside, so everything has to be squared. So 3 squared is 9. X to the 4th raised to the 2nd is a multiplying thing, so we actually make them x to the 8th. And on the bottom, 2 squared is 4, and y squared is y squared. That's your final answer for that one. It's a pretty long problem and pretty tricky to do. Lots of ways that you can make simple mistakes. So the best advice there is just try to take your time and make sure that you kind of work it out in steps. When we go to number 21, this one's actually much easier. There are no exponents raised to exponents, so this is just straight out multiplying across. So we're going to take 8 times -2, that gives us -16. The x's, 2 and 3, we're just going to add them, make it x to the 5th, and y to the 7th. That's all it is to that one. Okay, this time we're doing scientific notation. The first few problems ask you to turn 234,000 back into scientific notation. The key to remember is it always has to be between 0 and 1, so we start with 2.34 times 10, and if the decimal was here, we go 1 place, 2, 3, 4, 5. Means this exponent is to the 5th. Similarly, if we have one that goes the other direction, we still need to have a number between 0 and 1, so the closest thing to do would be to put the decimal point here. That's 4.57. The whole thing is actually negative, so you need to make this negative. And then times 10, and we're going to go 1, 2, 3, 4, 5. But it went to the left, so this is -5. Okay, number 24, now it's asking you to take a scientific notation number and turn it back into a regular number. So again, this one says take 6.2 and move the decimal point back 5 places. So here's 1, 2, 3, 4, 5. Means the decimal point should be right here. So we have 4 zeros. So our real answer to this is 0.000060. This one, same idea, except we're going to move the decimal point in the other direction 4 places. 1, 2, 3, 4. Looks like our answer to this one is 35,000. Okay, for this kind of problem, it's probably a good idea to use a calculator because what I want to do is multiply the 8.3 times the 3.4. When I do that, I get 28.22. And then for the times 10 part, 5 and -2, I just add them as if it was any other set of multiplying exponents, so I get 3. The thing is the 28.22 needs to be written in scientific notation completely, which means that it has to be between 1 and 10. So I'm going to move this decimal place to the left 1 spot, which is now 2.822. It'll be times 10. When you move to the left, you add to the exponent times 10 to the 4th. And likewise for this one, I'm just dividing, so I'll take 3.8 divided by 7.2. I get 0.528 when I round it. Times 10, and I subtract the exponent to the -6. So here, I'm going to move my decimal point 1 place to the right, so that it'll be 5.28 in correct format. Because I'm moving to the right, I subtract from the exponent. So -3 minus 1 is -4. Okay, this one should be really easy. This is just taking a function and evaluating it for a given number. So here's our general function, and we want to know what is it equal to when x is 0. So you don't even have to write this out, but you can if you'd like. If you're going to try to use a calculator, make sure you put the parentheses around anything you substitute. But when you get this, 0 squared is 0, times 4 is still 0, and minus 2 times 0, we end up with 0 minus 0. This one is equal to 0. And for -2, Same idea. Again, make sure you use parentheses if you're going to use the calculator. Negative 2 squared is 4, times 4 is 16. Negative 2 times negative 2 is positive 4. Our overall answer is 20. Okay, these are maybe my favorite kind of problems that we've done so far when we dealt with functions, is determining whether a situation is a function relationship. So, in this case, it's asking you, if you type in the name of a person, will you get one social security number? You have to think about this for a minute. If you have a very unique name, like for example, if your name was Christopher Michaelowski, well, that's kind of a unique name, and it's possible that there might only be one person with that social security number. But suppose your name is like John Q. Smith. Well, in that case, you might find that there are a lot of people with that social security number. So if a function doesn't work for every input, it really doesn't work. So if it doesn't work one time, then it's not going to be a function. So we would say no. And you might want to give a reason, which is because John Smith could lead to many social security numbers. Now see down here, the zip code to a state. If you can enter in any zip code, 15401 is Uniontown, it's the only zip code for that area, and that area only has one zip code. There's no way that you can have two zip codes to a different place. So for example, 15401 is only for Uniontown, Pennsylvania, and nowhere else. So if you enter in 15401, you get Pennsylvania, and that's it. There are no possible other answers to that, and it works for any zip code you can think of. 90210 gives you California, because it's for Beverly Hills. So, in this case, this one is definitely a function relationship.